talking about the synapsis of chromosomes in meiosis. Some key terms we need to know is crossing over, which is the swapping of genetic material, duplication, which is where the extra copy of part of the chromosome due to an unequal crossing over, and an inversion loop, which allows for maximal repair during meiosis. Other topics we need to know are acentric, which is when the gamete does not contain a centromere, dicentric, which is when the gamete contains two centromeres, and reverse displaced heterobranchial duplication, which is when extra part of the chromosome is on opposite sides of the centromere and is in the reverse order. So for individual 1, our dot is going to represent the centromere, and there's going to be a crossover event that occurs between J and K. So here is our sister chromatid, and as you can see, each color matches across, as well as the centromere matching in the middle, and now we're going to bring on our next strand. So now we're going to prepare an inverted loop to try and maximize our matching between our colors. So we're going to turn the first sister chromatid into an omega sign and then add the next sister chromatid. Once we add our second sister chromatid and we have all of our colors matching, we're going to add our loop to make sure that we maximize our colors. So now that we've added our crossover between J and K, which for our purposes is between white and green, we can see that we have 2 strands that are still the exact same as what we had before, and then 2 strands that are a little bit different. For our next 2 chromosomes, we're going to do the exact same thing because as we can see, our colors do not match all the way across. So now that we've made our loop and all of our colors match and we've maximized our efficiency, then we can go ahead and make our crossover event.